So let's create the function to calculate product sum. Let's call it product sum, and this function will take the array that we're calling list and the depth. Initially the depth will be 1. Now let's take a variable that will store the result, or you can say the sum, and I'm calling it sum is, and I'm initializing it with 0. Now I'm taking a for loop. Now if the element in the array is not array itself, then we can directly add it in the sum, else we gotta recursively call this product sum function to calculate the sum for that depth. So let's check if the element is instance of list. If it is an instance of list, then the sum is plus the product sum for this nested array. So let's call product sum, and let's pass this element, which is an array itself, along with the depth. So the depth for this array will be 1 plus the current depth, right? So each time we get deeper into the recursion, the depth increases by 1. Else, the element is not array, we can directly add it to the sum. So sum is plus the element. And finally, we will be having the result in the sum is variable, but it needs to be multiplied by the depth. So we will return sum is multiplied by the depth for this call. So now the implementation is ready. We just need to call this implementation. So first let's create an array, and then let's pass it to the product sum. So ARR equals to, let's pass 1, 2, let's take another array, 2, 3, 6, and array inside array, 2, 3, and 1. We need to take this one inside this array, and let's take 7. Now let's pass this array, and let's print the result. So let's run this and see. So we're getting 58. Let's check. 1 plus 2 is 3. This is 5 into 2, 10, 13. 13 plus 6, 19. 19, and now it is having order 3. So 5 into 3, 15. 15 plus 1, 16. Now it is having order 2. 16 into 2, 32. 32 plus this 19 is 51, and 51 plus the 7 is 58. So we are getting the right result.